So this is one of those ones where now you want to work backwards. Like, okay, here's what you want to make. How can you make it? And so you got to start to recognize some characteristics of the products. Right? This is the product. So what kind of product is this? Let's just think about what kind of product this is. Well, this is a tertiary alcohol. So that tells me something about what the possible starting materials could be. Also, I notice this tertiary alcohol has two ethyl groups, two of the same groups attached to it. Right? Two ethyls. So that tips me off about something, right? I said, wait a second. If I had a Grignard, I could have two of the same thing, right? If this was maybe start out as an ester, right? Esters I can turn esters into tertiary alcohols with two of the same things attached to it. So the problem asks you to do is, what's the ester route? And the other side, what would a ketone route be? So what I want you to do now, so they want an ester and they want a Grignard for each. Let's take 5 minutes, at least. You work on this problem right now by yourself. So, if we want to do this through the ester route, what we need to recognize again is these two groups are the same. So these two, this is what the Grignard is going to have to be. It's going to have to be a 1,2, an ethyl Grignard. So we're going to have an ethyl Grignard. Right, 2 carbons, 1, 2, and we're going to have obviously an excess of that, right? Because we need to add at least twice. And the ester part is going to have the phenyl ring, the acetyl bond O, and then it doesn't matter what kind of ester we choose, right? It just needs to be an ester, right? So these are the two things that would be needed to get to something. Obviously, that'd be step 1, right? Is this, and then step 2, of course, would be right protonation, that final step. You get to the tertiary alcohol. What if we want to go the ketone route? The ketone route, we actually have lots of options. You could do it a couple different ways. Right? So it's going to be a ketone. You could do it from this ketone, right? And then you have this react with one equivalent of the ethyl Grignard, right? You do it that way. What other way could you do it? You could do it with, oops, not that. Well, you could do it with this Grignard, a phenyl Grignard, right? And have that react with the ketone that has 2 ethyls on either side. That would work too. That'd be a ketone route to get to this product. And obviously, that's only step 1. Step 2, you need to still have the H+ for the protonation. So this is another one of those problems where we're given the product and we have to work backwards to see what this came from. Specifically, they're saying it came from an aldehyde and a Grignard. So first, let's look at what kind of product do we have. This is a secondary alcohol, and it has 2 different groups attached to it, right? So if it has 2 different groups, that automatically kind of eliminates, right? And only 2 groups, it eliminates esters, probably, right? Well, in some sense, it might. We know it's a secondary alcohol, so there's only certain things they can make from that. And they're telling us it comes from an aldehyde. So you got to know what, right? We're assuming you know what an aldehyde is. Right? We're going to decide what it's bonded to in a second. But how do I know which bonds are the ones being formed? It's a really good question. So how do you look at things in the reverse sense? It's actually the same way you looked at it in the forward sense, but just the opposite, kind of. Find the polar bonds. Find the atoms that are electrophilic, right? So if you looked at this molecule, which carbon is delta plus? Of those carbons, which one's the most electron deficient? Type it in the chat. Which one's the most electron deficient? 3, 3, 3. 3 is the most electron deficient. That's the one bonded to oxygen, right? Okay, so that's where the action's taking place, right? Anytime you have a reaction, somebody has electrons, somebody wants electrons. So carbon 3 must be where the reactions are going to take place, because that's the one bonded to the polar atom, the functional group. So which bonds must have been formed? Well, you look at 3 to 4 and 2 to 3, right? Because those are the atoms, or 3 to the H. So any one of these, right, spots could be where a new bond was formed. Do you all know ways to make carbon 4 a nucleophile? With a Grignard, right? Do you know ways to make carbon 2 a nucleophile? With a Grignard. We already just said, what did we just say? We said carbon 3 is electrophilic, right? It's delta plus because it's bonded to the oxygen. So that must be the electrophile. So there's carbon 3 now. And the thing we're going to bond to it is either carbon 4 or carbon 2. So what's one example of the aldehyde could be? If this was carbon 2 and carbon 1, what would the Grignard need to be then? The Grignard would need to be then carbon 4. How would I draw carbon 4 as a Grignard? Four, 6, 5. All right, so now, because I looked at this, I said, well, carbon 3 is bonded to oxygen. Carbon 3 is probably the electrophile working backwards. All right, there's carbon 3. So either I want to break 3 and 4 or 2 and 3, and I chose to break 3 and 4. So if I break it, that means this is the delta plus, carbonyl. I made carbon 4 the delta minus, the nucleophile, like a Grignard. And so there's my Grignard. Sorry, I forgot the BR. There's my Grignard. And there's my one example of an aldehyde. To look at it to disconnect it. All right, so what would the other route be? What would the other potential aldehyde route be? Well, it would be, instead of breaking 3 and 4, we'll break 2 and 3. So if I draw that aldehyde, it would be this one. Right? 3, 7, of course, still up there. 4, 5, 6. And the Grignard would have to be a Grignard on carbon 2. Two, 1. So that would be the other possible route than aldehyde. Challenge problem. What if I want to do the route with an H? What would that have started? What would I have started with? An aldehyde, a ketone, or an ester? If I want to make this exact thing, I want H to be my nucleophile. What would that be? So let's shrink this up. So I'm saying I want hydride to be my nucleophile. What would my electrophile need to be? It would be an aldehyde, a ketone, or an ester. So look back here. Which bond am I breaking? I'm breaking C3 and H. So what kind of product, what kind of starting material would I have? I would have, anybody? A ketone. If I reacted H minus a hydride with a ketone, I could also get this exact same secondary alcohol. And of course, you know how many different types of hydrides do you know? You know 2. I just draw it as H minus, but we know that they're different. There's sodium borohydride, and there's lithium aluminum hydride. This one's more reactive. This one's less reactive. But a ketone's pretty reactive, so we could choose either one here to make this reaction go. And we'll cover that more in a second.